Hi, this is a trigonometry revision video on trigonometry identities. Trigonometric identities, not easy to say, but worthwhile having a look at. Okay, we've got some review questions here, but I just wanted to show you a little bit of how I anyway, remember the 9 basic trig identities. We'll start off with sine squared theta plus cos squared theta equals 1. That's the basic sort of reference one we're going to look at. And from that, I'm going to spread out and just rearrange that a little bit. Here, 1 is on its own, so if I subtracted cos squared from each of it, I would get sine squared on its own. Sine squared theta equals 1 minus cos squared theta. You might have remembered that one. And we could also spin off that one. Now, 1's taken a turn of being on its own, and sine has taken a turn of being on its own. If I subtract sine squared from each, I could have cos squared theta equals 1 minus sine squared theta. So we've kind of got 3 useful formats for just out of that one sort of rule there. Okay, now there's another identity, and what I want to do is I want to take sine squared, cos squared, and 1 here. I want to divide through by sine squared theta in every spot. And that gives me another set of, if I divide sine squared theta under each of these, it gives me another version that I can then spin off from. So, if I think of sine squared on sine squared, don't I get 1? Yes, I do. Cos squared on sine squared. Now, you remember sine squared on cos squared was tan. Cos squared on sine squared is cot squared. And 1 over sine squared, which is kind of the reciprocal of sine squared, is cosec squared. Okay, so from that, I'm going to spin off another couple of versions here. We've got cosec on its own. Wonder if what we'd have to do to get cot squared on its own, we'd have to subtract 1 from each of it. So we'd get cot squared theta. If it's on its own, we'd have cosec squared theta minus 1. And another version from that one, we've had cosec squared on its own and we've got cot squared on its own. Let's have 1 on its own. And we'd have to minus cot squared, wouldn't we? So we'd have cosec squared theta minus cot squared theta. So we've got 1, 2, 3, 4, 5, 6 things happening so far. Alright, now let me see if I can just rub off this, because to create my next chunk I'm going to divide through by cos squared. To create this one here, I divided through by sine squared. Divide through by cos squared on each term. So, sine squared on cos squared, let me change over to blue. Sine squared on cos squared is my tan squared I alluded to earlier. Tan squared theta. Cos squared on cos squared, I think we can handle that as being 1. And 1 on cos squared theta, now that's the reciprocal or the upside down of cos squared theta, so that would be sec squared theta. So that gives us our third sort of main version, and we can have 2 different versions of that. Sec squared is on its own at the moment, the subject of the formula if you like. Let's see how we could get tan squared on its own. We'd have to subtract 1 from both sides, wouldn't we? Tan squared theta equals sec squared theta minus 1. And the thing that hasn't had a turn on its own is the 1, isn't it? So we'd have to subtract tan squared theta to get 1 on its own. Sec squared theta minus tan squared theta. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 trig identities here that we can use. And that helps us prove a whole bunch of stuff. Now, a lot of students might quickly write those out at the top of the page, or when they see a question where they have to prove left-hand side equals right-hand side and that sort of thing. But that's going to be pretty handy. And so we did all that from just this first identity here. So if you remember that, and you remember that we can divide through by sine squared theta in each of them, or divide through by cos squared theta for each of them, and get a whole new section. Now what I like about this too, let me just highlight something that's worth thinking about. Anytime there's a 1 in a proof that you need, you can replace it with a whole bunch of different things here. Look, let me just circle all the bits that are equal to 1. I mean, for a start, we could replace 1 with sine on sine, or cos on cos, or cot on cot, if that helped our working. But we could also replace it with sine squared plus cos squared. We could replace 1 in any of our equations with, or our proofs. We could replace it with cosec squared theta minus cot squared theta, or we could replace 1 with sec squared theta minus tan squared theta. So that's another little clue there. We could use our 1s wisely if we can. Alright, so having that up your sleeve is going to be pretty handy. Let's see some proofs for some trig identities here. Now cot. Cot is 1 on tan, and you've got a tan there as well. So if we did that, if we did the cot down to 1 on tan and just did tan, now tan can be tan over 1, can't it? We can divide the left hand side, the bottom, by 1. Tan goes into the top once, so we get 1 times 1 there. Final answer of 1. So here it doesn't look like we've got much happening, but notice there's a 5 in the front bit and a 5 in the second bit. We can actually factorize, so don't forget we can factorize things. And cosec squared minus 1 is one of our identities that we could turn into cot squared. So if you had a look at the previous page, or your listing, if you wrote it out, that equals that on one of our 9 trig identities there. Okay, let's have a look at this one. It's kind of interesting. We've got a 2 in there. Now I did say that 1s were handy, but anyway, if our left hand side can be what it says there. And what I've done here is I've split up the 2 into that there and that there, because I have some identities for tan squared theta plus 1 and cot squared theta plus 1 separately. Tan squared theta plus 1 is sec squared theta, cot squared theta plus 1 is cosec. So that sort of turned into that, and that sort of turned into that, and that's what we want. So we just have to say equals right hand side, and we're in business. So there's lots of different ways we could do things here, but we split that 2 up into 2 separate 1s, so then we could match up the identities. Okay, all the best there. There's a whole heap of strategies you can use for those trig identities, and it'd be worth getting a lot of practice at them, because they're good marks when you can get them. peterblakemaths.com. Catch you next time.